Okay, so when we talk about all the topics in physics of your from your whole syllabus, so not all questions are going to included in your paper number 6. Most of them, just like from the measurement chapter, from the thermal chapter, and from light section and electricity. So paper 6 questions are related to these topics, right? Because in these topics we are also having lab practicals exam, but for those students who choose alternate to practical, so they just need to solve the theoretical concepts related to that specific topics, right? So mostly if we try to solve paper number 6, and if we specifically talk about the physics ATP paper, that is paper 6 in IGCSE or paper number 4 in O levels 5054. So those questions are basically related to the common sense, or let's suppose if we are handling some apparatus or if we are measuring something, so that is normally related to daily life calculation type, right? So the ATP of the physics is more easier than the chemistry and biology, because chemistry and biology are related to some chemical and other type reaction that we don't observe in our daily life. But for physics, we in daily life we observe different type of measurement, we solve different type of uh, problems in our daily life related to all this process. So just like we use thermometer in our daily life, we use measuring tape, we use stopwatch and other instruments. So that's why most of the questions are related to our daily life example. So that's why it is not very difficult to solve, right? It includes that how to
Right, sir.
read the reading from scale, how to read the reading from any other instrument, how to read reading from stopwatch, voltmeter, ammeter. So that type of questions are mostly included in it. So starting from the first question, specimen paper 23. So a student investigate how partially covering the top of a beaker of water affects the rate at which the water cools. The apparatus used in figure 1.1 is shown. Okay, so we are having a thermometer over here. Read and record the room temperature shown on the thermometer. Okay, so this is the first question, and you see that the first question is very much simple. You just need to read the reading from thermometer. So the major concept of asking this question is that either student is able to understand the division, because we solve the questions of graphs, right? So we know that how to divide the divisions equally. So if you want to find out the temperature from this thermometer, so what is the temperature?
21 degrees.
21 degrees, because we know that between 20 and 30 we are having 10 divisions. So each division is of 1 degree. So that is 21 degrees Celsius, because SI unit is also mentioned on the thermometer. And the second part is the student pours 100 centimeter cube of hot water into a beaker. So we are having 100 centimeter cube of volume of water. She places lid A on the beaker. This leaves half of the top of the beaker undercovered as shown in figure 1.3. So they are talking about this one, right? So beaker is covered with half lid. And next, she records the temperature of the water in the beaker and immediately starts a stopwatch. She records the temperature of the water every 30 seconds. Her readings are shown in table 1.1. So these are the reading. We will check it out. Then she repeats the procedure using lid B. Now we are having lid B, and lid B is placed on the beaker like this, right? Almost quarter circle is remaining, otherwise all part is covered on the beaker. So now we are having readings, and complete the readings headings row in table 1 and time column in T 1.1. So we need to first fill out the SI units of the quantities mentioned over here. So first we are having time. So what is the SI unit for time?
Second,
Second. So we have to write only S over here, that is for second. And what about temperature?
Celsius.
Celsius, because we are using the thermometer which measures in Celsius. So that is also very simple, right? So 1 mark is for the correct heading row in table 1.1. And the other 1 mark is for the complete the time column in 1.1, because that is also very simple. Any idea what will be the time? There is a hint in the
30,
question.
60.
Yes, because there is a hint in the question, 30 second is mentioned over there. So we just need to write with the reference of 30. So starting from 0, 30, 60, 90, 120, 150, 180, right?
Yes.
So you can see that 2, uh, 3. So this is the question for 3 marks, and that is not much very difficult. And now describe a precaution that should be taken to ensure that the temperature readings are as accurate as possible in the experiment.
We could repeat it.
Okay. But if we want to take accurate reading, so what we have to do for that accurate reading, because we already have many readings in the table that is mentioned, so that is already over there. Okay, so while we are taking the reading, so because there is a change in temperature, right? Okay, so in the example of the table, we saw that the temperature is decreasing from 80 to 68 for beaker A and 81 to 73. So when we are calculating or when we are recording the values, so we have to very careful when we are taking the reading. So we have to wait until the temperature is going to decrease or temperature is going to increase. Or second is that when we are recording the value from the thermometer, so we have to avoid that parallax error. Parallax error is that, let's suppose if we are using this thermometer, so normally we record reading by placing our eye level in front of the reading, right? Let's suppose if we are reading the values from this thermometer, so our eye level should be in a straight line like this, right? Let's suppose if you are recording the reading from this side. So this is the not a right way to calculate or to read the reading from any instrument, right? So that is known as parallax error, right?
Right.
So avoid the parallax error because most of precautions are new for us because we don't talk about precaution in paper 2 and paper 1, paper 4. So that's why most of few things are repeated in P6. So once you solve the question, so that will be easy. Okay, so when we start writing the precaution, so we discussed that one precaution which is related to the parallax error. So the first precaution we can write it as avoid parallax error while measuring the temperature from thermometer. And the second thing we can also add it over here. We just need to write a one precaution. So the second one is that we have to wait until reading stops increasing in the start of the experiment, right? So initially when temperature is rising, so we have to wait that temperature will stop at a specific high temperature. So then we will start the reading while temperature is dropping, right? So that is also important. Otherwise, let's suppose if we just start experiment in hurry, so we don't actually record the highest temperature and we will start in between somewhere between high and low temperature. So that's why we have to wait until we reach the high temperature before starting the first reading of the experiment, right? That is, we are talking about this one.
All
Okay.
right, sir.
Okay. And write a conclusion to this experiment starting for which lid the rate of cooling is greater. Justify your answer with reference to the result. So that is also not very difficult. You are having a reading from the graph. Lid A start with temperature 80 and lid B start with temperature 81. So observe the reading and just try to answer the question. You have to find out which lid the rate of cooling is greater. So which lid is going to cool down more faster? So you have to answer with reference.
Lid A.
Lid A has a greater, very good. So first we write that lid A has a greater rate. So lid A has a greater rate of cooling. And if we want to write the reason, so what is the reason? Because according to the table, we are starting from 0, then we will take our final reading at 180 seconds, right? So the temperature will fall more frequently as compared to the beaker with lid B, right?
Right.
So you see that this is not much very difficult. We just need to write with the reference of table. So we can write it as because the temperature falls more frequently between 0 to 180 second as compared to the beaker with lid B, right?
Yeah.
So that is also very much simple. And further, suggest a change to the apparatus that produces a greater difference between the rates of cooling for lid A and B, and explain why the change produces a greater difference. So now we have to make a change in the apparatus that will produce a greater difference between the rate of cooling for lid A and B. So now we have to cool down more quickly as compared to the previous comparison. So what will be the best change? Because there are multiple change, we have to explain only one.
The lid could be of a reflective material.
Okay.
So
And
that it's a bad absorber of heat.
bad absorber of heat, but we need a good absorber, right? Because if it
Oh,
absorbs amount of heat, so then it will transfer into the surrounding, right? And it is not
right.
possible that you only make change in lid. There are multiple options. You may also make change in beaker. So that is also possible. So that they are not asking about only lid A and B. Change is made up in any type of material which we are using in this whole experiment. Either you change in the material of the beaker which is made up of, you change the shape of the beaker, or you may change the dimension of the lid. So multiple options are there.
So sir, we can increase the surface area for the beaker.
Yes. So one option is we studied in the evaporation process. that if we increase the surface area, so the rate of evaporation will increase, so temperature will more quickly go down, right? So that is also very simple process. So there are multiple options. So let's suppose if we go with the high cross-sectional area or with increasing cross-sectional area. So increase cross-sectional area of beaker. And if we talk about the explanation, so we know the explanation that increasing the area will increasing the area will increase the rate of evaporation, right?
Yeah.
And further, you may write that either we use a thick lid, let's suppose. One option is you may also check out in the marking scheme that will also help you to study it and to know about some other factors. So one of them is thick lid. Either we use thick lid, so that will be a transfer of energy will be greater as compared to the previous option, or we may use a plastic beaker, because plastic is a bad conductor, right? So it will lose heat more quickly as compared to the good conductor. So multiple options are there. You may check out from the marking scheme also. So that will give you more idea about it, right?
Yeah.
Because that is related, this question is specifically related to the thermal chapter. Okay, moving to part E. Another student thinks that the cooling rate is directly proportional to the percentage of the surface area uncovered. Okay, so that they are talking about the same reason which we write in our previous part. He draws a graph of cooling rate against the percentage of uncovered area to investigate this. Describe how his graph line shows whether the rate of cooling and the percentage uncovered surface area are directly. So they are making a graph between rate of cooling and the percentage of uncovered surface area. So what will be the shape and how will be the line of the graph? That is also very simple question.
So as the percentage of uncovered area increases, the rate of cooling will increase.
Yes, and both are directly proportional, right? It is also mentioned in the question. So what will be the shape of the line?
Straight.
A straight line. Because we know that when we are talking about the directly proportional concept, so let's suppose if we start from zero, so there will be a straight line starting from the origin. So graph shows a straight line starting from origin, because rate of cooling is directly. And if you notice one more thing, before solving part 2 of the previous section, that is D, if you try to solve question part E, so that will also give you the hint of the previous question, right? So most of the hints are already in your question. So that's why this paper is not much very difficult. It's directly proportional to percentage of uncovered surface area. So we already get hint from this part. So that's why This is also not much very difficult. Surface area. Moving towards the part F, that is the last part of this section, this question, that is of 11 marks. And we solve the question, and that will very much easy. And we don't know that we solved the question of 10 marks till now. So a student in other countries are doing the same experiment. State one factor, they must keep the same to obtain similar reading.
The same volume of liquid?
Same volume of liquid, very good. So same volume of liquid is compulsory. And one more important thing, let's suppose if in my country, if temperature is very much low, so I have to maintain the temperature of liquid the same as the other students are doing in the other countries, right? So the initial temperature of water will also be same, right?
Yes.
So initial temperature must be same for liquid. And if we talk about some other factors, so we have to use the same lids. That is also very much important, right? Because we studied about the factor that change the rate of evaporation or rate of the cooling because of the change in the apparatus. So we have to use the same lid. If someone is using a lid of some thickness, so all students in different country use the same thickness of that lid. Otherwise, it will be difficult. And same goes for the material of the beaker. We have to use the same material for each beaker, which students are performing in different countries. So there are multiple factors, and that is also not very difficult to answer. So that relates with the all the previous parts of this question. So any confusion in question one?
No, sir, it was easy.
Okay. Because normally this paper is very much easy. I start before it because you will get an initial idea that how to solve the question and how questions are going to be in your P6. Okay, that is related from electricity part. So in the first line, they are talking about the circuit, and circuit is mentioned over here. We are having point P, we are having point Q, we are having power supply, and a crocodile clip on the right hand side, shaped like a crocodile, and there is a resistance wire. Okay, so now you have to, when we are solving the question, so we are having power supply resistance, so we have to know about the basic concept of electricity, that what is resistance, how resistance will increase, and how current will change. So all these points are very much important. So starting from the first part, on figure 2.1, draw a voltmeter connected to measure the potential difference. Okay, so we have to connect a potential difference in diagram 1. To measure the potential difference across terminal P and Q. So we have to connect voltmeter. So we have to connect the voltmeter. So how we need to connect the voltmeter in the diagram? If you remember when we are talking about the ammeter and voltmeter, so ammeter will always connect in series combination or parallel
A series?
series. So that's why ammeter is already connected in series combination. And if we have to measure the voltage, so we have to connect voltmeter in
Parallel?
parallel combination, right? So that is also very much simple. So we connect 1 voltmeter over here, parallel combination, and then we connect, right? Because one side is connected with the resistance wire and second wire is connected with the power supply. And same goes over here. One is coming from the power supply, second is connected with the resistance wire. And the next part, the student connects the crocodile clip to a length L90 centimeter of the resistance wire and the measure the potential difference P and Q and the current I in the circuit. Read and record in table 2.1 the values V and I shown on the meters. Where is table 2.1? So here is table 2.1. So we have to read and record the values. Okay, so first of all, if we read the value from voltmeter, so what is the value from voltmeter we are getting in this?
2.6.
2.6. Okay, so 2.6 from the voltmeter. And what about ammeter? Ammeter is different one, because voltmeter is simple and ammeter is okay. The simplest way to find is that first you check out the division. We are having 0.2 and 0.4. So what is the difference between zero point 0.4 and zero point 0.2?
0. 0.0, I mean 10, 10.
Okay, so if we subtract 0.4, 0.2 from 0.2, so it means we are getting 0.2. So there is a difference of 0.2, and the difference of 0.2 is divided between 10 equal divisions, right?
Yes.
So it means if we further divide it by 10, so we will get another 0 that will be equal to, so 0.02, that is for each division. So one division is made up of 0.02. And now we are having how many divisions? 5, 6, 7, 8. So we are having 8 divisions. Or in simple words, we can say that, let's suppose in the middle at this point, we will get 0.3, right?
Yes.
Because there is a value of 0.3 between zero point 0.2 and zero point 0.4. Now there is 5 divisions between 3 and 4. So we know that 0.32, 0.34, 0.36, 0.38, and 0.4. So 5 division will divide like this, right? So what will be reading over here in ammeter? 0.3. Okay, reading will be like this. I will draw it again over here. We are having 0.3 over here, and then 1, 2, 3, 4, 5, 0.4. So it means we are having how many divisions? Now we are having
5.
5 divisions, and we have to divide it into 1, because 0.4 and 0.3, we are having a difference of only 1. So we just need to divide 1 by 5. So we will get 0.2. So it means each division is made up of 0.2 value. So we are having a pointer over here at this point. So we are having 0.32, 0.34, 0.3.
0.36.
Yes, right. So that is also very simple. Just you read from the graph, so that the same process will go over here, right? So we are getting
Yes.
2.6 from voltmeter, 2.6 from voltmeter over here, and 0.36 from ammeter over here. And now we have to complete the remaining values. That is the B part of this question. I think they are also asking SI units. Let's read the question first. Connect the crocodile to length 60, 40. She measured the potential current. He reading our table. Complete the columns heading in. Yes, so first we need to complete the headings. So first we need to write the SI unit for volt. So what is the reading for, or the SI unit for voltage?
V.
V, volt. And what is the SI unit for electric current?
Ampere.
Ampere. A. Good. And further we have to complete the calculations, that is resistance and dr over L. So if we need to calculate the resistance,
So it will be VI.
it will be equal to V over I, the simple formula or the basic formula for resistance, right? So we just need to divide 2.6 by 0.36. So you will get 7 point.
7.2.
Yes. And same goes for the other value, 2.5 divided by 0.49, you will get 5.1. And the third part is 2.3 divided by 0.74, that will be equal to 3.1. And R over L, you just need to divide resistance by length. So resistance is 7.2 divided by 90, so that will be equal to 0.08 for the first part. And in the second part, 5.1 divided by 60, that will be equal to 0.085. And the last 3.1 divided by 40, that will be equal to 0.07 round of 8, right? So almost they are equal to 0.08, right?
Yes.
And calculate and record in table 2.1 the resistance of each length of the wire. Use the reading from table and equation R is equals to VI. So we already calculated the value, right? So it
Yes.
means we have done this part and we also done this part, right?
Right.
Hmm, Part D, another student suggests that the value of R over L for each length of wire should be same. State whether the results support this suggestion. Justify your statement with reference to values from the result. So we need to write with the reference, because when I'm also writing the value of R over L, so I also tell you about that all values are approximately equal to 0.08. So it means the value of R over L are same at different value. So we need to match the R statement with reference to this value. So if we write it the statement, so the calculated value are approximately equal to 0.08, right? And the SI unit is ohm per centimeter. And the justification is that if we perform the experiment with the changing length, and so when we are changing the length, so resistance will also change, right? And
Yes.
if you remember that there is a reference of R is equals to rho L over A. So if we increase the length, so resistance will also increase. So there is a direct relation between resistance and length. So that is the justification of this statement, because R is directly proportional to the length. That is the formula. R is equals to rho L over A. So if the value of length change, resistance will also change directly, right?
Yes.
So this is the part D of this question. Okay, so we find out the reason that why the value is approximately equal to 0.08, because length is directly proportional to resistance. So if we are changing the length, resistance will also affect by it. And suggest one difficulty which explains why different students doing the experiment carefully with the same equipment may not obtain identical result. So what will be the difficulty while they are performing the experiment? So let's again go back towards the setup and try to find out that what will be the difficulty that a student face while performing the experiment. Okay, so problem is that when they are performing the experiment, so the most important part in this that we have to set a fixed length, right? Because most of the students are performing the experiment, so they need to fix the crocodile clip at a fixed point, right? Because length must be fixed for or must be same for all students. So there will be a problem while fixing the crocodile clip at the exact position, right? So we have a problem while fixing this crocodile wire on this resistance wire. So there will be a difficulty in this experiment while connecting the crocodile clip with the resistance wire. Or there is also a problem that when we are going to connect this crocodile clip, so we have to fix it with accurate measurement. So there will be a difficulty in measurement also. So most of the problem is related to this crocodile clip and the resistance wire. Otherwise, all connections are not much very difficult. Those are very irregular practice connections, so that is not much difficult. There is only a problem with crocodile wire and the resistance wire, right?
Yeah.
So we may write it as students find difficult to connect crocodile clip with the resistance wire at the same position. So that is the problem, right? And further part F, because all questions are of 1 mark, so you just need to write to only one or give only one reason. So that is not much very difficult. A student finds that during the experiment, the wire becomes hot because there is a high current. He decides to use a variable resistor to prevent this. Draw an X on a circuit in figure 2.1 to show where a variable resistor is connected for this purpose in the experiment. And in the sketch below, sketch the circuit symbol for a variable resistor. So let's first draw the symbol for variable resistor. Do you remember the symbol for variable resistor?
Yes.
Okay. So first we need to draw a rectangle, right? And then,
Like a line through it.
yes. So we are having a symbol of variable resistor and we have to draw an X on circuit 2.1. Okay, so we have to connect a variable resistor in the circuit. Yes. So where we have to connect the variable resistor?
On the resistance wire.
But that is already providing. Actually, the question is when current is passing through the wire, right? So this wire is getting heat up, right? So they are talking about this wire. We are having two wires in the experiment. One is resistance wire. We are not talking about that because that is for the changing length. Because we studied that if we change the length, resistance will also change. So that's why we are using resistance wire. But if we talk about a normal wire, so if we increase the value of current or when the current passes through the through the normal wire, so the temperature of the wire will increase and it will become more heat up as compared to the initial condition. So we have to connect the variable resistor. So if wire is getting heat up, so we increase the resistance. So that will decrease the current, so wire will not heat up. So that's why we have to connect a variable resistor. So we have to connect variable resistor in series, right? Because we know that in series combination resistance will be maximum. So we have to connect resistance in series. And where we have to connect the resistance?
On the wire that's going to heat up.
Yes. So we are having a power supply. So either we going to connect a variable resistor over here, or either we connect on the right hand side over here, right? Because it depends upon the positive terminal, because current moves from the positive side. So it depends upon the positive side. So normally according to the diagram, maybe this one is the parallel because key is connected over here. So it's not important. So you just need to mark X over here or either X over here, right? Any question?
And no, sir, all clear.
Okay, so that is the end of this question number 2. That is also of 11 marks. We also done this part. So these two questions are of 22 marks. Let's move towards the third. That is from the light chapter, because we are having lens and all the prism, all experiments are there. So mostly we are having experiment related to light also. Okay, again we are having a starting paragraph and a related diagram, and we are having a bulb on left hand side, and there is illuminated triangle in the center. Then we are having lens, then we are having a screen. Okay, so the illuminated object consists of a triangular shaped hole in a piece of card. So basically this piece of card is placed over here, right? So there is a triangular shaped hole in the card. Okay, figure 3.2 shows full size the illuminated object HO. Measure and record the HO of the triangular shaped hole. So you have to measure the HO. So how you measure the height HO?
By subtracting the area of.
But area is not mentioned there. You just need to measure HO. So what is the simplest way to measure HO? Just think about it.
Scale.
Scale. So you need to use a ruler over here to measure this HO, because I am on a screen and I have option to increase or decrease the length over here, and scale is not also mentioned over here of the paper. So you just need to measure it with the normal ruler. You just place a zero on the one side and then measure. And if I measure with the help of ruler, so I am getting the value around 1.4 on the screen. So the important thing is you just need to know about that how to measure the length. So you just need to use a ruler over here, right? Not a very difficult task.
Yes.
Okay, further, the distance between the illuminated object and the center of the lens is set to 20 centimeters. So basically this U is the distance between the illuminated object and the center of the lens. Okay. The screen is moved until a focused image of the illuminated object is seen as shown in figure 3.3. Okay, so we are getting an image on the screen, and initially we are having a upright triangle like this, but we are getting a picture or the image on the screen like the inverted. So why we are getting inverted? Because we are using a converging lens, right? So that's why we are getting inverted image. And HO is the height of object and HI is the height of image. So the student repeats the procedure for U is equals to 30 and U is equals to 40, 50, 60, and his results are shown in table 3.1. Measure and record in the first row of the table the height of the image. Okay. Okay, so the value of U is mentioned over here, right? We have to write the value of HI. So what will be the value of HI? Again, we have to use the ruler over here, right?
Yes.
And if I again use the ruler, so it will be around it is 4.5. You may also check with the ruler if you have ruler with you. So you just record the reading from the screen just for roughly estimation. So I'm getting 4.5 from this diagram. And what will be the magnification? And the formula for magnification is also mentioned over there. So you see that formula are also given for the table. So you just need to use the formula. So for magnification, the height of object. So we measure the value of height of object from previous diagram, that is 1.4, and 1.4 divided by 4.5. So you need to divide these two quantities, that is height of object divided by height of image.
0.31.
0.31. And also all other values are already mentioned. So our part is just to complete for 2 mark. One is for writing this value. Second is for this value. Okay. Now we are having a part of the graph. Plot a graph of u centimeter and against m axis. You don't have to start your axis at the origin. Okay, so because graph is not much very big over here, so it is not compulsory for you to start from zero. But it's up to you. If you want to start from zero, it's up to you. Otherwise, if you want to start from one, two, or any other specific value, you may start from there also, right?
Okay.
Okay, so now we have to first check out the value, and we have to draw a graph between u and m. So we have to find out the value of u and m. So initial value of u is 20 and we are getting m 0.3. So u is on y-axis in centimeters and m is on x-axis. So first we need to divide the divisions, right? So to divide the division, first let's check. The least value of m is 0.31 and the highest value we are getting 2.8. So it means if we start from 0, let's suppose, so we have to draw 0 till 3 on x-axis, right?
Yes.
Because all values are between 0 and 3. And for y-axis, our lowest value is 20 and the highest value is 60. So it means if we start from 0, so we have to draw from 0 to 60 on y-axis, right? Okay, let's check how many divisions are we have on x-axis. So starting from x-axis, we have to just take care between values that we are having value between 0 and 3, and we are having 1 2 3 4 5 6 divisions or 6 boxes, right? So let's suppose if we start from 0, so we may draw a very wide values like this: 1 over here, 2 over here, and 3 over here, right? Okay.
Yes.
And further, if we draw for y-axis, so for y-axis we remember that we have to remember the least value is 20 and the highest value is 60. So 1, 2, 3, 4, 5. Okay. On x-axis we are having 6. 1, 2, 3, 4, 5. On y-axis we are having 5. So it will be more easy that if graph is from. Okay, so they are talking about that we don't need to start the graph from 0, right? So for y-axis we may start from 20, right? 20, 30, 40, 50, 60.
Okay.
Or we may start from 10, right? So that graph will not start from the baseline. So let's suppose if on y-axis we start from 10, so this value will be 20 and this value will be 30 and this will be 40, 50 and 60, right? So it is the distribution,
Yes.
and it's up to you that how you divide the whole graph. But try to make it very easy for you, otherwise marking the values will get complicated because we have to mark the value also. So let's mark the values. First, I take the screenshot of this reading, otherwise we have to move again and again. Okay. So the first reading is we are having U at 20 and M at.
0.03.
So first we
Point.
need to, yes, first we need to find the 20. So 20 is between, 20 is over here on y-axis, and we have to find out 0.3. So where will be 0.3? So let's just magnify this graph for now. Okay, so we know that we are having 20 divisions between 0 and 1. So it means 2 division is equals to 0.1, right? So it means 2 divisions is equals to 0.1. So we need to find out 0.31. So 0.1, 0.2, 0.3. So it will be around over here. 0.31, our first reading, right?
Yes.
And on y-axis, we are having 20. So we mark over here. This is our first point. And the second value is 30 and 0.93. So 0.93 is almost between these 2 points, right? Because this is 0.9 and this is 1. So value will be in between 0.9 and 1. And we have to mark on 30. So let's mark around over here, right?
Yes.
And next we have 40, 40 and 1.6. So 1.6 will be over 1, 2, 3, 4, 5, 6. So this is 1.6. And it will be equal to 40 over here, right? And next 2.3, it will be 1, 2, 3, 2.3 over here, and value is equals to 50. And this will move straight up like this over here, 50. Finally, we have 2.8. So 2.8 will be over here. Any confusion?
No.
Okay. Remove the extra line. Okay, so 2.8 and the final value will be equal to 60. So 1, 2, 3, 4, 1, 2, 3, 4, 2, 3, 4. Over here, we are getting our last point, 60. So I think it is a straight line, right? So you need to draw a line and that will be equal to, yes, it is a straight line. So let's complete this line. So we are getting best fit line between 1, 2, 3, 4 point. One point is little bit out, but that's not a very big deal because not all readings are exactly matched while performing the experiment, right? There must be some errors and some uncertainties in the values. And now we have to find out the gradient of the graph. Show clearly on the graph how you obtain the necessary information. So how we find the gradient from the graph? If you remember in while we are solving the past paper, so we also find the value from the gradient that we have to select 2 points on the line and then we find out the gradient, right?
Yes.
So let's suppose if we take 2 points, you may take 2 points from the highest and the lowest point. So let's suppose if we take the lowest point, any point from the graph, it depends upon you that which value you are taking from the graph. Let's suppose if we take this value and from the highest somewhere we will take this one. So we need to write readings over here. What will be the reading? 2.5 over here for x-axis. So this is for the x-axis, and on y-axis we are having 55.
55?
Yes. So 55 on y-axis. So same repeat the process on the left hand side. We choose this one. So it will be 0.5 on x-axis and 23 on y-axis, right?
Yes.
And for gradient, we have to use the formula of gradient that is the same like the mathematics. But if you are not doing mathematics, so that is not. So m is equals to y2 minus y1 divided by m2 minus m1. Sorry, x2 minus x1. So that's why we take 2 points. Let's suppose if we are taking this value as x2, okay, x2, y2. So these value will be x1, y1, right? So y2 minus y1 means 55 minus 23. 55 minus 23 divided by 2.5 minus 0.5. 2.5 minus 0.5. So now just divide all these values so you will get the gradient.
16?
16. Okay. So we are getting gradient 16. And if you check the answer scheme, the answer is that you gradient will be lie between 15 till 17, right? So we are getting 16.0. So it means our answer is right. And now again the same concept. Describe one, because in this question we are having a graph of 4 marks, so that's why this question is short. So describe one difficulty that might be experienced when measuring the height of the image. Suggest an improvement. So the same question that is also asked in the previous question, but only a setup is different.
The ruler?
Yes, so while measuring or while we are measuring the length from ruler, so that will be difficult because let's suppose if we place hand between the ruler or if we not place ruler in a straight line, so or if we place ruler in between the path of the image, right? Let's suppose light is coming and if we place the hand in between that image, so that will be a difficulty. And what we need to make it more improved. Okay, so there is a suggestion over here. So first we write the difficulty. So the difficulty is to measure the reading. Measure the height or measure the height of image. I am writing in short over here. So during measurement, we place our hand between screen and path of light. Okay. So when we are going to record the reading from the screen, so ultimately our hand will be in between the path of light and the screen. So it means the original image will not going to be correctly form on the screen because now our hand is in between the lens and the screen. So the shadow of our hand will also form on the screen. So what is the improvement or what we have to do for this process? That if we are using a solid screen over here, right? So image will form only in the front, right? Let's suppose if we are using a tracing paper, like we are using a translucent screen, either it is made up of tracing paper or a thin plastic type paper. So image can also be seen from the back side, right?
Yes.
So we can easily measure the height from the back side of the screen. So that will be easy. So there will be no problem in the path of light and the screen. So we have to use a tracing paper or any type of translucent screen to measure height of image, that is HI, right? So that is the solution or the improvement. Any question, any confusion?
No, it's all clear.
Okay. So now we are having a last question, that is question number 4. And question number 4 is almost on the same pattern, or we can say that the pattern of this P6 is same in all the questions. Either you solve any type of paper of any year, so that will remain same. Because we solve the starting questions, so they are asking about the calculations. And if we observe the final question, the final question is different from all other questions because they only ask about the whole setup. So that is all question related to the theoretical concept. So let's move toward the final question and let's check out what is the difference in that question. Okay, so the student is investigating the factors that affect the size of the crater hole a ball makes when it is dropped into sand. So actually we are dropping a ball from height and when it strikes the surface of the sand, so it will make a hole, right? So plan an experiment to investigate one factor that affects the size of the crater. That apparatus available includes metal ball of different sizes. So this is our apparatus. We are having metal ball, a tray of dry sand. Write a plan for the experiment. So now we just need to use our little bit imagination and then we have to plan the experiment. And in your plan, you should state which factor is being investigated, state a key variable to keep constant, list any additional apparatus needed, explain briefly how to do experiment, including what is measured and how this is done. Okay, so you may draw a diagram if it helps to explain your plan. So diagram is not compulsory, but if it helps your plan so that you may draw a diagram. Okay, so first of all, starting from the very first part, we are having a metal ball of different sizes, right?
Yes.
So first we have to write the state which factor is being investigated. So first we have to talk about this one. So we are having metal balls of different size. So if we are using metal ball of different size, so which factor will be changed
The
related to the ball?
size.
The size of the ball will change and the mass of the ball because we have to talk about the crater, that hole which is going to be made in the sand. So that depends upon the weight of the ball. If the mass of the ball is heavy, so the hole will be greater, right?
Yes.
So first we need to write the first statement, that will be like this, that the mass of the ball will be changed according to the size of the ball. And next, if we are talking about the constant factor, so we need to also tell that which factor we are going to keep constant in the experiment, right? So let's suppose if we talk about experiment, so let's suppose if we are having a tub of sand over here, there is a tub and there is a sand in it. So we know that if we are using a sand in the tub, so the depth of the sand will remain same, right? Because the height of the tub is same, just like the ripple tank when we discuss about the ripple tank. So same goes over here, that the depth of the sand or the height of the tub remains same, right? And second, if we are using different balls, so the height of the ball from which we are going to drop, so height of the drop must remain same, right?
Yes.
Because we are using different weight of the ball, so it means one constant factor we are having here, it is the height. So we have to drop a ball from a constant height, right? So it means when we are talking about a constant factor, so the constant factor is the height of the drop and the depth or the height of the tub remains the same, right? These are the variable and constant factor. And next we have to find out the other, list any additional apparatus. So now we have to talk about the additional experiment if we require some additional experiment. So what additional apparatus we need required, or we need over here to measure any other thing? Because we mentioned height over here. So to measure the height, we use additional experimental apparatus, which is,
Ruler.
yes. So we have to use a ruler over here. So to measure the height, we also have to use a ruler. So we need a ruler over here. We need a ruler to measure the height. And according to our experiment, we need one more thing. Till I am writing this third point, think about from the other 2 points.
A balance.
Yes, very good, because we need to also measure a mass and a balance to measure the mass. Okay, so now let's move towards the next part. So now we have to perform the experiment. So now we write to the steps that how we perform the experiment. So first we need to measure the height. measure the height and drop the ball from that height, and when ball hits the sand, so we also have to measure the depth, right?
Yes.
And then measure the depth or the crater on the sand using caliper or rulers, because we have to measure the depth. So vernier caliper is also useful for us. Otherwise, we simply use the to measure the diameter, right?
Yes.
Or the second option is we measure the diameter.
Sorry, sir, were you saying something?
Yes, I'm just telling that. So these are the four important steps that we write for our experiment. Then the remaining part is the state how to obtain reliable results for this experiment. Suggest a suitable graph to be drawn from the result you made. Okay, so two parts are remaining. We know that we have to repeat this experiment because we have to note more than one reading, because one reading is not necessary and not fulfill our requirement. So we have to repeat for the other values, because we have to change the ball and we have to again measure the diameter, right? So we are having variable factors, so we have to change and then record the readings again. So now the additional part. So let's suppose if we are using three balls, right? One is of 1 gram, one is of two, and then we are having three. So let's suppose we are having three balls. So finally, so let's suppose if we are having three balls, so we record the readings for three different balls. And finally, when we record all the values for each ball, so we need to find out the average value, right?
Right, sir.
So finally, we have to find out the average value. Find the average value for all sets of reading. And what will be our next step? The most important thing that, because they also ask some factors that is very important for us to keep in mind. Measure the diameter accurately, because that is most important, because there is a sand, if we try to push it hard, so it will change the size of the diameter. So measure the diameter accurately. And what will be the other?
The mass?
Hmm, we also need to measure the mass of all the ball, and then because once ball hits the sand, so there will be a change or sand will going to be compressed over there. So we have to measure the diameter at different places, right? Don't worry, question is of only 7 marks. I'm just writing some additional point also. So that will help you to know about the experiment and how experiment is going to be performed. Because mostly we studied about in questions in three of the parts, we get the idea that how experiment is going to be performed. So now we have to write the steps by our own. So that is the only difference in this question from the other. From other question, they already mentioned the steps. We need to find out the value. But now we need to write the steps, the values or the idea is already mentioned in the question. And one more important thing is at least record 5 set of values. So we need to take at least 5 set of values. And they again ask about one more important thing that is related to the graph, right? So last but not the least, we have to tell about the graphical representation. Okay, which color will be good? Okay, taking the blue color for the graph. So if we talk about the graphical representation, so for the graph, so we know that the depth of or the diameter of the sand will change with the mass of the ball, right? So it means graph will be drawn between the diameter or the depth of the sand versus the mass of the ball, right? Or the weight of the ball.
Yes.
Graph will be plot between the diameter of the ball and weight or mass of the ball, right?
Yes.
So that is the end of this paper number 6. I hope you will find it not much difficult as compared to the other paper. And if you solve the other paper 6 of bio and chemistry, so I think this will be easy as compared to the other, right?
Yes, this was the easiest.
Because we already have all the thing, we already have the formula, we already have mentioned all the thing in the question. You just need to read the statement and find the hint from the question. So all hint are already given in the paper, but only last question is that you need to do your buy sell. So that is not much difficult because pattern remains same, and once you solve the question from different papers, so you will get the idea. So most of the pattern is repeated. So the most important thing that you need to first focus on your P4, then P1. Then we will time by time you solve paper 6 also. So most important first paper is of your P4. So P4 is most important. So try to solve question related to P4 and you will also get the idea how to solve the question from P6. Okay.
Right, sir.
Okay.